Hello, today's video is going to discuss z-scores and standard normal distribution. So a z-score is a value that shows how many standard deviations a data value is from the mean. When the z-score is positive, the data value is above the mean. When the z-score is negative, the data value is below the mean. And when the z-score is equal to 0, the data value is equal to the mean. So for example, we've been learning about normal distribution. So here is our bell curve, and our mean is here somewhere. And then this is 1 standard deviation, this is 2 standard deviations, and 3 standard deviations. So for example, if these were test scores, so let's erase those and say that the average test score was a 78 and the standard deviation was 2. So that would make this 80 and 82 and 84. And it would go this way too, but let's just deal with half of it for now. So if I wanted to know the z-score of 81, that would be 1.5 standard deviations away from the mean. Because the mean is 78, the standard deviation is 2, so 81 is 1.5 standard deviations from the mean, meaning the z-score of 81 is 1.5. So that's just a generic idea of what a z-score is. To find a z-score, we're going to use this formula. This capital X is a Greek letter called chi. This is mu, and this is sigma. Those are all Greek letters that represent different things in statistics. So the z-score is z equals chi minus mu over sigma. So the data value minus the mean divided by the standard deviation. So for example, in number 1, it says a radar detector records the speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8 miles per hour, find the z-scores for each data value. We're just going to do part A together. And in order to use our formula, we need to have the data value, the mean, and the standard deviation. So z is equal to the data value, which is 52, minus the mean, which was given to us in the problem, it's 46, divided by the standard deviation, also given to us in the problem, that is 2.8. When we evaluate this, we're going to find that 52 miles per hour is 2.14 standard deviations above the mean. In numbers 2 through 4, the problem is basically going to give you 3 of the 4 variables in the z-score formula and ask you to find the 4th one. So in this problem, it tells us the mean number of total miles ran last week by each member on the track team was 4. So let's pause. It just told us what the mean equals. With a standard deviation of 1.2, and Clay's z-score was 2.5, and it wants to know how many miles did he run. So we want to solve for x, or chi. So we have 2.5 is equal to chi minus 4 over 1.2. So to solve for chi, we're going to multiply both sides by 1.2. That'll give us 3 equals x minus 4, which I've been calling chi, but let's be honest, it's an x. If we add 4 to both sides, we get 7 equals x, and then that tells us that he ran 7 miles. So standard normal distribution is a normal distribution in which mu, or the mean, is equal to 0, and the standard deviation is 1. the distribution is standardized by the z-score. So if you look at this, here's our chart. The mean is 0 and the standard deviation is 1. So if I asked you what the z-score of negative 1.5 was, it would be negative 1.5. So the value is the same as the z-score here. So I want us to complete a couple of examples together using standard normal distribution, but in order to do that, we need to look at these calculator steps. So take a minute and take a picture of this or write it down or whatever works best for you. In order to do this on a TI-84 calculator, first, the thing that it's asking us is we have golf scores in a tournament, normally distributed with a mean of 76 and standard deviation of 2.6. Find each probability. So here it asks the probability that the z-score is less than 2.1. So if we have a value, or here's our curve, here's our mean, and here's the 2.1 standard deviations away. It wants to know what's the probability of selecting any value less than a z-score of 2.1. So our calculator is going to tell us what percent of the graph is shaded, and that is the same as our probability. In order to do that, I'll show you first on a TI-84. The first thing we have to do is go to Window, which is the second gray button at the top, and we want to set our window to be -4, +4, 1, 0, 0.5, and 1. Okay, so that's all you have to change. And then you have to hit second mode because otherwise it'll clear out information that you put in there. Then we want to go to second variables, which if you didn't see is this button here beside clear. Then we're going to go right to draw, and we're going to hit enter on number 1. If you have an older TI-84, you are going to type these things with commas. So you will type the lower value, then you will type the upper value with a comma between them, then you'll type comma 0, comma 1. So the 0 and 1 are going to stay the same. For the newer TI-84s, this is what it'll look like. So I'm going to show you how to type this in. That -1e99, that means negative infinity. But to type that in, you would type -1, then you would hit second and comma, which is above the 7 to get that little e, and then 99. That means negative infinity. If you wanted positive infinity, you would just type it without the negative. So we want the probability that z is less than 2.1. So it can be any negative, like it can go all the way to negative infinity, but the most it can be is 2.1. So that will be our upper boundary. We're going to leave the mean as 0 and the standard deviation as 1, and we're going to click draw. And it's going to show us this graph that kind of looks like our bell curve. And I don't know if you saw before those numbers popped up that it had it partially shaded in. You always want to double check that your lower and upper boundaries are what you typed in, because sometimes if you don't clear everything out of your calculator, it will give you it'll repeat the same thing that you did before. Like it'll keep giving you the same answer over and over instead of giving you the new answer that you typed in. So you always want to clear everything out between each problem. You do not have to do your window over each time though. Okay, so the area is what we're going to use. The area for this one is 0.982136. So we're going to convert that to a percent, and we're just going to call it 98.21%. That is the probability of a z-score less than 2.1. To complete this problem on Desmos, we're going to go to functions, and we're going to click on dist for distribution, and we're going to click on normal distribution. This automatically gives us a mean of 0 and a standard deviation of 1, which is what we want. Now we need to click this Find Cumulative Property. Okay, that is going to give us, I said property, cumulative probability. So this is the same thing as what we're doing on the TI-84. So our minimum is going to be negative infinity, so you can just type infinity and it will automatically convert. And the maximum, because we want a z-score less than 2.1, will be 2.1. And you're going to find that we get 98.21% again. And if you zoom in on this chart, you're going to see where it cuts off over here at about 2.1 and shades everything below that. So let's do number 8 as well, and back to our TI-84. When you hit clear, it's going to take you back to this screen. You have to clear that out as well. But for those of you who have an older TI-84, I want you to see this because this is how you will type yours in. It will have, you'll still go to second variables, and you'll still go over to draw, and you'll still hit number 1. But it will not take you to this screen. Instead, it will pop up shade, norm, parenthesis. So you have to type in -1E99. Again, to get the E, you do second and comma. But you have to type in the lower boundary, then let's hit enter. There we go. So first you have to type the lower boundary, comma, the upper boundary, comma, 0, 1, and then end your parentheses, hit enter, and it will give you the same graph that we got on the newer ones. So moving on to problem number 8, we're going to hit clear to get out of the graph, and then we have to clear this screen too, or it's going to keep giving us the same answer over and over. So we don't have to redo the window, but we're going to go back to second variables, go over to draw, hit enter. On this one, we first have to find the z-score because right now we just have a value. So we're going to take this 81 and we're going to find the z-score for it. So z equals the data value minus the mean. The problem told us the mean is 76, divided by the standard deviation, which in our problem is 2.6. And we're going to find that 81 has a z-score of 1.92. So instead of looking at our original problem, we want to find the probability that z is, okay, let's look again, greater than. Z is greater than 1.92. That's what we're going to be looking at now. So back over to our calculator. If it has to be greater than 1.92, then 1.92 has to be our lower boundary. Our upper boundary is going to be positive infinity. So to type that in, we're going to hit 1, second comma for the E, and then 99. That means positive infinity. We leave the mean and standard deviation alone, and then we hit draw. We give it a second to update, and as you can see, we have lower boundary 1.92. Honestly, I don't know what this 9 is. I don't know why it shows up. I don't know what it means, but it does not seem to affect the answer, so just ignore that. The upper boundary is positive infinity. That is correct. So our area, if we move the decimal point 2 points to the right, that converts it to a percent. So this is 2.74%, and that is our answer to number 8. I'm going to run through that one more time on Desmos as well, because I know several of you do not have a TI-84 at home. So again, we go to distribution in the keyboard, and we go to normal distribution. We check mark the CDF box. In this one, our minimum is that 1.92 z-score. Our maximum is positive infinity, and it seems like if we just tab through that it leaves it at positive infinity, and it gives us our percent. So we move the decimal to the right 2 spots and get 2.74%. And then you can see over here that it has shaded in everything above the z-score of 1.92. And that is the area that we're finding, which represents the probability of that value. So on number 9, I don't actually want to go through the problem with you. I just want to let you know that this means that the z-score is between two numbers. So your lower boundary will be negative 0.2, your upper boundary will be 1.8, and you won't have any infinities in this one. Okay. So that is all that I wanted to go through with you. Thank you guys so much for listening, and I hope you have a fantastic day.